So I will start now. Vincent, can you put yourself on mute? Thank you. So very good afternoon, everyone. I am Manish Unyal, Senior Marketing Manager from Elsevier India team. I have with me my colleague Vincent Paul, who is the Solution Sales Manager for Elsevier Engineering team. And on behalf of Banaras Hindu University and Elsevier, we would like to welcome you to our webinar, Geographical Field Work During the Pandemic, Virtual Exploration of Kosi Plain using Geofacets. Today's webinar can help you learn how Geofacets can facilitate the virtual exploration during the pandemic. Now, I would like to cover a few housekeeping rules. Everyone should be watching in the listen only mode, but if you do see a microphone icon on your screen, please be sure to keep yourself on mute. There will be 2 presentations and then plenty of time for your questions. Your comments and questions are warmly welcomed. You can use the question box to submit your questions at any time. And today's webinar is being recorded, so we will share a link with you after the event is complete. Now, I would like to request Professor Riram Sakal Yadav for the welcome address. Professor Yadav is the HOD in the Department of Geography at Banaras Hindu University. His area of specialization is applied geography and regional planning, remote sensing, and also GIS. Some major projects that he has undertaken are as project in charge are urban environment and quality of life in Imphal city, Manipur, application of IRS 1C data for land use mapping of Itanagar capital complex. He has many quality publications to his credit, and he was the member of executive committee Arunachal Pradesh Itanagar from 1999 to 2003. He was the professor and head department of geography Arunachal University Itanagar from 1992 to 1999, and then again in 2003 to 2005. A warm welcome to you, sir. The floor is yours.
Okay. Very good afternoon to the academicians from the east, and good morning to the academics from the west. It's a pleasure for me to welcome the team of experts from Elsevier, especially Dr. Wilson. It is to mention that to act as kind approval from the director, Professor A.K. Tripathi, who has been kind enough to approve sharing of the logo from the Elsevier. It's my pleasure to welcome Professor Alam, Professor A.P. Goswami, Professor A.K. Singh, Dr. Naren Verma, and Dr. Meena, who has been readily coming forward and giving cooperation for virtual field work for Geofacets. Various resource persons are also very much welcome. It is my pleasure to welcome the various source persons and student community from Asian countries as well as from different countries of the world. Geographers in the field-based science, geography is a field-based science, and field itself is a laboratory for geoscientists in general and geography in particular. Cross-section, longitudinal profile, transect diagrams help geographers to understand the nature of surface configuration, lithology, and structure on the Earth's surface. Different sub-disciplines of geography are developed with diverse nature and scope. Accordingly, tools and techniques are sometimes juxtaposed or diagrammatically opposite to each other. It is pleasure for me to announce that the curriculum of geography is provided with 2-week field work for excursion and training to graduate students at 3 macro regions of India. Postgraduate students are also taken for a duration of 3 weeks, cutting across diversified plateau, coastal areas, and structural valleys of Eastern Ghats and Western Ghats of India, and structural valleys mainly Narmada, Tapti, Mahanadi, Son, Godavari, Krishna, and Kaveri. Most unfortunately, during the COVID-19 pandemic, sciences have adversely been affected because field work cannot be carried out in time. Under this crisis, Professor Sarfraz Alam came forward and invented feasibility to self-guided field-based study in which region PG students were born and brought up. It was some blessing in disguise of COVID-19 pandemic. I would like to say that Kosi is one of the important river basins which is unique in the sense that it has many often changed its course of channel. Sudden changes in slope from the north to south led to deposition of sediments in the mouth itself, and channel has a tendency to move westward. Although many bunds and levees are constructed to reduce the vulnerability from the floods in backswamp areas, but still sometimes vagaries do take place. Still, people are trying to learn lessons and experiences to mitigate impact of flood to minimum. Thanks.
Thank you, Professor Yadav, for this warm welcome. At this time, I would now like to invite Professor Sarfaraz Alam to share his presentation with us on geographical field training during pandemic done by Department of Geography, BHU. Professor Alam is a professor in Department of Geography, Institute of Science, Banaras Hindu University since 2018. He is also an adjunct faculty at the Center of Bhojpuri Studies, Faculty of Arts of the same university. Dr. Alam joined Banaras Hindu University as an assistant professor in November 2005. Prior to this, he was associated with the Institute for Defense Studies and Analysis, New Delhi, as a research assistant from 2002 to 2003, and JP University, Chapra, Bihar, as lecturer 2003 to 2005. He also worked as a reader of geography discipline in School of Sciences, Indira Gandhi National Open University, New Delhi, for a brief period in 2011. Dr. Alam holds a PhD in political geography from the School of International Studies, Jawaharlal Nehru University, New Delhi. His research interests include history of Indian geography, geography education, and geography of South Asia. A warm welcome to you, sir. The floor is yours now.
Thank you, Manish. Am I audible?
Yes, sir. Loud and clear.
All right. Thank you, Manish. Good afternoon, everyone who are from India, and hello to everyone from different parts of the world. At the outset, I would like to thank Mr. Winston Paul of Elsevier for inviting me to make this presentation on geographical field training during the pandemic. Now, in the very beginning, I would like to tell you that this presentation is based on my experience of teaching a paper, geographical field training, to at postgraduate level. Okay, my presentation, as you can see, is structured as follows. Firstly, we would like to discuss about thinking of challenges of field training during the pandemic. Then I will discuss field training components in geography syllabus of post-graduation at Banaras Hindu University. After that, I would throw some highlight on field training during normal times and field training during the pandemic. And after I will also discuss in this presentation techniques applied by the students of postgraduate in the field and what have been the learning outcomes, And in the end, I would speak a little bit about what are the unique features of this new technique. And finally, I would display a field-based report prepared by one of the students of our department. Now, as it is known to all of you, geography is a field discipline. So we cannot imagine of doing geography without fieldwork and without maps. So as has recently been said by Parkinson, that geography without fieldwork would be like science without experiments. However, COVID-19 pandemics has presented a new and unexpected challenges for field-based learning. And pandemics and associated lockdowns by different countries and economic slowdown have actually reduced opportunity for field-based learning. So much so that now it is many scholars are talking about end of field for field-based disciplines. However, I would argue that field-based learning is always a challenging task, and there are many uncertainties which are involved during the field work. And it requires a lot of, therefore, it requires a lot of creativity. And the challenging time require most unique kind of creativity. So field is still there, and we have to be creative to visit there. What I say, field-based learning has actually not ended. Rather, its mediums have diversified, and remote options have expanded geography educational reach. So now it is up to us to explore what are the options which are available before us in order to conduct a field trip during this challenging time. Now, let me talk about the geography papers in which field training is a strong component. And these are the papers which I teach. One is village survey, socioeconomic. Now in this paper, we take students to a nearby village for 2 to 5 days, and they do household survey. Second is geography of rural settlement, in which again we take students to a nearby village where they do social mapping of the village. And finally, we have geographical field training, which we teach in the 3rd semester. And in this paper, we take a student to the peninsular India, particularly eastern and west coast of India, for 2 to 3 weeks. And this is a 2-credit paper. So I have been teaching this paper for the last 3 years. And for the first 2 years, I took the students to the peninsular India, but unfortunately, we could not take students to peninsular India this year. And we had really a very difficult time. So we started to think what to do. So before we discuss about what I did with my students, so let me tell you what actually we do in this paper. So as I told you that field trip to Peninsula, we take students for field trip to Peninsular India for 2 to 3 weeks. And this is a purely supervised on-site learning. There are 3 teachers who are there to guide and help students on sites. And the major techniques that are involved in this field trip are making observation, measurement, identification of rocks, and sample taking, village survey, sketching, and then taking of photographs. Now, students are assessed by evaluating their field diaries. They are also taught how to write field diaries, and also we teach them how to write field reports. And their assessment is based on their performance in field diaries and field reports. Now, this year, because we could not take the students to the field, so there was a lot of period of uncertainty. We were not sure about what we will do in this paper. Even the university was also not very clear. So finally, university told us to do some kind of innovative thing so that the students do not suffer. So as I told you that some sort of creativity is needed when the time is challenging. So we tried to develop an alternative method of field training. And that method we have named it a remotely guided field training. And the second, we changed the place of field training from peninsular India or east and west coast of India to home region, or the region where students were presently, then they were there at the time of the field trip. Now, we did pre-field briefing and training as part of this. Before actually initiating the field work, we delivered 4 online lectures of 1.5 hours each, and to explain objectives of field trip, techniques of field trip, particularly the skills of observation, what to observe, how to observe, then what features to sketch, and then also what features to take photographs. Then we also introduced a very important component, that interview of key persons. We felt that the key persons, particularly those who are aware about different specific regions of where students live, if they can be interviewed, and these people can actually tell them about the regional specificity and regional characteristics in the way they perceive it. And then we also taught them how to identify key sites, then search for materials and resources, and we also taught them how to write a report. Now I would like to tell what are the different steps after once we train them through online lecture. Then after that, we prepared a table containing physiographic regions of India, ranging from macro to third order region, as proposed by Professor R.L. Singh. His book is quite famous. He has written a book on India, a regional geography, with the help of those students who stay near the campus. So they could come to the department, and myself and the students prepared this table. And then we gave option to students to choose their own field. So they could choose their home region or the region where they were presently staying. And now after that, once they choose their region, then we scanned and shared relevant materials and resources from my personal library, like book chapters, articles, and maps on the specific regions with the help of, again, these students. And then we also scanned and shared relevant chapters of Professor R.L. Singh book, India Regional Geography. We downloaded and shared book chapters and articles, books from internet with the help of these students, like A.T.S. Learmonth and O.H.K. Square, famous book, India and Pakistan in General and Regional Geography. And also we shared a travel guide, Lonely Planet India. And as a result of this, they got some base material and they got some basic information about their own regions. And most importantly, we maintained regular contact with the students, so that in case of any doubt, in case of any confusion, queries, they can always contact the teachers. Now, the students travel in their region individually, and they didn't travel to all parts of region, because these regions are, even though they are the third order region, they are very big regions. So they mainly travel on specific sites, those sites which are unique, and those sites which define the characteristics of the region, of the representative sites, what we call, and then made observations, sketched, and took photographs. And those sketch and photographs actually were very typical of these photographs and sketch actually were the one which were very typical of the cultural and physical features of the region. And then they also interviewed local resource persons to know unique characteristics of the region. They also spoke to their own family members, particularly those who were older people. And finally, they also used relevant literature and math to write the report. What was the learning outcome? All the students, first thing that in this pandemic, all the students were able to submit their report. This in itself was an achievement. And while going through their reports, I could say that about 10% students wrote excellent report, I must say. And 40% of the students did reasonably well. Others just wrote the report. What was their feeling? I was very happy to see some of the students were so excited that they also wrote their feelings of doing this exercise. So few wrote that I got the opportunity to know about my region well. I developed a feeling about my home region and a curiosity to know more about it. And few of them wrote, now I feel confident to undertake fieldwork on my own. Now, what is unique about this technique that is remotely guided field trip? Firstly, there is change in the techniques of learning. So there is shift from on-site guided field training to remotely guided field training. That means the teacher who is sitting in Banaras University, he is always in contact with the students. The students are in the field, and out of this connectivity, all confusions, queries of the students are removed. And then there is shift from group-based field learning to individual field learning. Now, unlike the past where we used to take all the 70 students to the field, now it was not possible. It is not possible. So individual students were visiting their respective regions, different spots within their respective regions. So therefore, it was individual based. It was individual field learning. And then third is there is change in the place of learning. As I told you, that the shift is from peninsular India to home region. So students, because after all, we are not going to tell them the geography of different parts of India. The focus of this paper is to train the students in how to conduct field study. That is the core of this paper. And then there is also change in the name of field training technique. So we have named it remotely guided field training in home region. So thank you. And after this, I would just like to share now, is it visible? This is a report.
Yes, Professor Adam, we can see it.
Which was prepared by one of the students. She's from Mithila region of Bihar. I mean, it's a cultural region. And she did her report on Mithila East. She did her fieldwork on Mithila region. And basically, it's her name is Anjali Kumari. She is a student. She was then a student of third semester. Now she is in fourth semester. So I'll just scroll whatever she has done. So this is introduction, geology, location and extent, then geology and landforms, vegetation, natural resources, cultural aspects. And you can just see how much effort she has put in settlement, my village, then important city, important industry, crops, ethnic dresses, regional food, festivals, fairs, language and dialects, historical buildings, caste and religious composition, connectivity, interview, and conclusion. That means she had tried to bring out the holistic nature of the region, the total characteristics of the region by using not one method of just field observation, but also by talking to people, by sketching, by doing many other, using many other techniques. So you can just see it is based on observation, then photograph. These are the tools she has used, a sketch, and then interview of people, then finally literature review. And this is the region, you can see. These are the typical Mithila art. Unique vegetation. And then natural resources. And then you can see this settlement, typical house types in Mithila region. And then she has this sketch, this house types, typical house type of Mithila region. Various components of the house and their functions. And then this is the morphology of her village, the social morphology of her village that she has done. This is representative of the region. You can see some other components that she has drawn. This is an example of puja. That was, you will see, this is fort of Darbhanga. You can see pond of Rambagh fort. Then some crops she has seen. She has also sketched all the different techniques which are used for the storage and preservation of grains. You can see here. And then these are the agricultural implements which are used in the region for in the cultivation of crops. These are all agricultural implements for cultivation, storage, and processing of crops. Then here is the ethnic dress, male and female both. Then she has written about regional foods. Then these are the idols which are very popular in that region. Then a very iconic place, garden of Sita Ji, which is there in that region. And this is historical building of this region, Rajnagar Fort. And these are some of the white, some components of those forts. So you can just see how much effort she has put in order to bring out the uniqueness and individuality and distinctness of that region. And this work is partly based on field work, partly based on literature review, and she has used a number of techniques to write this report, and you can easily, okay. So with this, thank you very much. It's over from my side.
Thank you, Professor Alam, for this insightful presentation and for sharing this very creative report from your student. I'm really impressed with the creative ways you have tried to facilitate the geographical field training during the pandemic. So now I would like to introduce Dr. Sandra Merton. Dr. Merton joined Elsevier in 2010, and she is responsible for the ongoing developments of Geofacets. She managed the successful release of several major Geofacets project enhancements, including the launch of more than 1 million easy-to-access figures and tables, and new redesigned Geofacets user interface. In her current role, she focuses on the development of analytical decision support solutions and services to help answer applied geosciences problem in the industry and academia. She has MSc in structural geology and tectonics and a PhD in thermochronology and tectonics from the VU University in Amsterdam, the Netherlands. At this time, I would like to extend a warm welcome to Sandra, and I will also hand over the floor to her for her presentation. Over to you, Sandra.
Thank you, Manish. And yeah, welcome everyone. Good afternoon for those in India, or good day if you're somewhere else in the world. Thank you also very much, Professor Yadav and Professor Alam, for sharing how you've tackled the field training during the difficult times of the pandemic. It was really interesting. And yeah, I just want to concur to what Manish was saying, that it's a very creative way to still enable to do field work in these challenging times. What I would now like to talk about is, so you mentioned the literature review, things that you can look up already in existing publications. And yeah, this will be the key part that I will show in this part of the presentation. So the objective will be looking into the Kosi plain. We already heard some details of the Kosi plain area from Professor Yadav in the introduction. And I will show you how using Geofacets, which contains a lot of scientific literature, and Google Earth to show how this could support. So very important, not replace field trips, but how it can support geoscience, but also geographical field work, also during regular times or in times of a pandemic, whereas we saw also in the previous presentation, where there has been a faster shift towards remote solutions and remote learning opportunities. So with that, I just first also wanted to reiterate some of the things about why fieldwork is so important. So you heard in the introduction that Manish did about me, that I have a background in geosciences, but whether in geosciences, whether in geography, field training and fieldwork is really important. That's the place where you gain hands-on experience. And so what you see on the right is actually a picture of me in one of my first field trips. And yeah, I still remember that, like, nothing can replace like seeing things for real, and like seeing, in this case, a folded layers. I heard about it in the first courses, but then seeing it really makes it real. And then, of course, developing field skills, collecting data, and very importantly, learning how to observe. Like we saw all the really nice sketches. Here you see an example of one of my sketches. One on the left is one of my early sketches. I still had to learn a lot, how to observe, how to really capture information. And then on the right, you see a few years later where after I'd learned to like observe a lot more, to capture a lot more. And so with that, of course, then in the end, synthesizing and writing a report, as we just saw in the example. And then in the end, of course, with the objective to, if you're a student, to successfully complete the course, if you're a researcher, to really achieve your research goals. So with that, I just wanted to share like that, yeah, in my experience, and this is also what we're hearing from a lot of our Geofacets users globally in Europe who are using Geofacets for this purpose, in Latin America, in different regions. It's key that you prepare, because there is, of course, a lot of challenges. You have to first really get a good idea, what is the objective, like what am I trying to accomplish? What is already known about the area. So this is where the literature review comes in, and then where are the gaps? Then also, what does the area look like? Are there roads? Can you get there? Are there important reference points or specific places that are really important for the area? Is it accessible? Is it safe to reach the locations? And then also, of course, the additional challenges that we see today in the case of a pandemic, where it's even more difficult to go on a field trip. And so with that, yeah, we're going to combine Geofacets and Google Earth to virtually explore the Kosi plain, showing how that can support field training and field trip efforts. But before I go there, let me just briefly explain you what Geofacets is for those who are not familiar with it yet, so that you know what you're going to see. So I just wanted to explain also a bit of background. So Geofacets was created because we got a lot of feedback that there is a lot of information and data buried in scientific publications. So here you see an example, an article. It can contain lots of text, lots of images like maps, plots, graphs, and within that, lots of information is embedded in those data types. So whether you're a geoscientist, a geographer, a geophysicist, there is lots of information that you could capture from maps, from profiles. And yeah, because in these fields, they say a picture is worth more than 1,000 words. And I think that really applies. Like if you would want to describe the same as what you can see in a map, you need like a lot of words to describe that. We also heard that a lot of time is spent on searching and not so much on really then thinking about the data and interpreting and analyzing, up to 80%. And so some of the challenges that you have to go to so many sources, it's difficult to access those different sources, spending a lot of time. And then also very important that in the end, ideally, you want to use the data. And yeah, that's an example that we will really focus on today, where I'm going to show you how, if you have maps that are spatially referenced, how you could then analyze those in Google Earth and then really put scientific data such as physical features like the tectonics, the sedimentary basin, like the sedimentary characteristics of the region, in this case the Kosi plain, how if you can combine that with some of the features in Google Earth, like the satellite imagery, and also the ability to actually explore a lot virtually, how that can really give you a head start, but also important, how that could help to then put the observations in an overall picture and hypothesize and synthesize the information, which is, of course, as we also saw, a really important part of doing such a field training and then writing a report. So yeah, in order to try and tackle some of those problems that I just described, we created Geofacets, which the idea is that we aggregate a lot of publications from a lot of different sources. So not just Elsevier, but also, for example, the American Geophysical Union, Geological Society of London, Geological Society of America, and then extract all the maps, the figures and table, and enrich those. So that you can really dive to the data very quickly. And then, of course, very important, also a read-only PDF of every source article to get that context and to then understand more during any literature review tasks that could be part of that such a training. Then easy discovery. So what we also did is we enriched the maps, figures, and table with metadata. So for example, what is the location of the map? What type of map is it? Is it like what topic? Is it geology, geography, hydrology, climatology? So that you can quickly zoom in on an area of interest, because typically in geosciences, in geography, also in geophysics, that's like where you start. You focus on a specific area, and then you want to know all the things that you need to know about that area. And then seamless integration. And this is coming then to the part of being able to then take that data and, for example, put it into Excel to analyze a table, or put it into Google Earth to analyze it spatially. And with that, yeah, just some examples of how Geofacets can help. It can help to find information on a specific feature or topic. So if it's maybe to answer research questions, or if you're getting up to speed on that topic, that's where Geofacets is used yeah, by our global user base. It can be used to instill research principles in the next generation of geoscientists and geographers, preparing them for real world careers with hands-on training. And then the example that we'll cover today, to find maps and other data to virtually explore your area of interest, to really prepare and support your field training or field trip efforts. So with that, we'll go to the Kosi plain. So yeah, just here on Google Earth, we can see the area of the Kosi plain. We can already see the Kosi River. And as we heard in the introduction, like it has a very changing profile from north to south, like from starting very high in the Himalayas. You can see that here in the north, and then downstream in the end, going towards the east, and then joining the Ganges River. So what we can then do is, I will now switch and go to Geofacets and then show you how we can find information, data, maps for some of the examples that we saw in the report. So for example, geology and landforms, vegetation, climatology, and of course also drainage patterns, which is really important in the case of the Kosi plain. So let me switch to Geofacets. You should now see a Geofacets. So as you can see, a big portion of Geofacets is made up by a map, and that's to really enable spatial searching. So you can see here in the top, you can of course search for a specific keyword, or we could also enter Kosi plane, but we can also use the spatial search. And the advantage of the spatial search is that you don't rely on someone, having mentioned that area. So whether it's written in different ways, or whether they described, a different place, locality, you can eliminate that by just doing a spatial query. And so what we can do here in the area of interest, I will draw a box to pull up maps, figures, and tables for this area of interest, for the Kosi plane area. And so you'll see, let me enlarge the map a little bit. You can play with that. So you'll see on the map, you see all those blue bubbles. Those are the numbers of maps, figures, and tables. And this is dynamic. If you zoom in, you can really start to explore spatially. If you zoom in and out, you can see that the clusters break down. And so this is one way how you could virtually start exploring your area of interest. You could maybe start here towards the north, and then go south, and then really see what kind of information is available for that area. What you see then here in the middle is the preview of the maps, the figures and tables. And if you want to see it in the context of the article information, so the article title, but also figure caption, then you can easily switch view, and then you have a combined view. And of course, we can also see, so these are 320 results just for the spatial search. If you want to see it at document level, so this is really the original publications, then you can switch to this view, and we can see it's 80 documents. And here you can get an idea of the type of articles that we see. And so with that, we can actually already gain quite some information, because I see here that it's the Kosi is an alluvial fen, it's a mega fen. We can see that there is information about channel migration patterns, river discharge. So we can already gain some first insights. And of course, you would dive deeper during the literature review part of the course, of any field training or field preparation parts. What we can also do is refine the results, and this is where those metadata come in. So for example, we could start with geology, or we can say, let's first find a tectonic map to first get the large view. So I'm going to filter for tectonic. And then I'll zoom out a bit, and we can see we indeed directly get these type of tectonics maps. And what we can then do is we can open the details and then view the results. So we can take a look at the map here. If you want to see it bigger, you can always view the original image so that you can look at it in a bit more detail. And then we can see that this is from, in this case, from an Elsevier publication. We can see the source, the article title, and then here below all the metadata. And then, of course, everything else that is in the article. We can see there's lots more maps. There are tables with data, and like that, we can start to explore. What we can then do, and yeah, just also to highlight, of course, the source article is there. So you can first look at the abstracts. We can see here Himalayan rivers have very unusual strontium characteristics. So this is more about the isotopic characteristics. And we can also take a look at the read-only article viewer to really get the context. So here you can see, then you can browse through it page by page to then read the article. What we can then do to really start analyzing is we can download the map. So about 70% of the maps is georeference, which means that they can open in geospatial solutions such as Google Earth. And so for that, I'm going to download this map as a KMC file, and then I'll just download. And so it will load, and then you can see it downloads the file. I can save it in a folder on my computer. And then I could open it. And so here I'm now switching to Google Earth, because I want to show you how we can then combine those maps with the views that we get in Google Earth. So as a first step, what we could do is take a look. We could, for example, change the transparency a bit to see. Let's zoom in a bit on the Kosi area. We could change the transparency, then we can see how those rivers nicely aligned. This is, of course, a large scale map. we can see the main front thrust here, the MFT, so like a big thrust of the Himalayan front. And so like that, we can collect like different maps. Of course, you can also take a look at pictures or at plots, depending on the topic. So, but as I mentioned, like first we were looking into the geology and the landforms. And so what I did in the same way as what I just showed you in Geofacets, I looked up a few maps, looking first at the more the geology. And so here you see another example. So I'm going to switch off this map. And so here you can see I just saved all these maps in a Google Earth place, like a workspace. So I called it the Kosi plane, and then I saved all these results under it so that I can easily build a spatial picture of the field area. And so here we can see another map. So this is really even larger scale. So we can see here the Himalayan range. Then here we can see the main thrust. And then here we can see the floodplains of the Ganges River. And so with this, we can get a first idea. Then I found another map. So here, let me switch this off. And so like that, you can go back and forth. So here we can see the Kosi Plain area. Again, we can see the Himalayan fold and thrust belt. Here, the main thrust. And what you could then do is really also analyze the topography, for example. So one question we could ask ourselves is there any relation, for example, to the tectonics and the geology of the area, and then the morphology, the topography that we see? We already heard in the introduction that the Kosi River is going from really high in the north and then lower elevations. And what I would like to show you now is by making a transect. So here I created one, but just to show you, it's really easy. You can create locations or polygons or lines. In this case, I will click a line, and then I can just make like a north-south profile. You can choose the color. Let's say that we keep red for folds and then blue for profiles. Then I can make this profile. I can call it north, south, transect, and then save it. And what we can then do is analyze the elevation, for example. So first, let's see if we just change the transparency. Sorry, I have to switch to that map. If we change the transparency, we can see how the map coincides. Here you can see nicely how the high topography coincides with the main thrust. What we can then also do is analyze the transect. So I will, sorry, let me just put it like that. I will use this option in Google Earth, show elevation profile. And what it will do is it creates an elevation profile. And in the same way, we can now see what we could also already see from the satellite imagery, that here it's really high elevations. And then here, as soon as we cross that main thrust, it's much lower elevations, around 50-55 meters here in the Kosi Plain area. And again, let me just switch off the map so that you can see that same way how that can show us really the huge differences in topography. What we can also do is, of course, digitize other features. In this case, I took the Himalayan thrust as an example, but you can choose different features, rivers, depending on your interest, to digitize just using these options here for polygons or for lines to then create such features. And then after that, what is nice is that you can change the map, you can switch it off, and then we still have the location of that main thrust left. What we can also do is, like that, as I mentioned, I collected like some different maps. So here we have another map of the study area. This one is giving a bit more detail into what the rocks look like. So I have seen from this map that this is mainly quaternary, and then here much older types of rocks towards the north and also towards the south. Then another map here, much more zoomed in. This is more focusing on the geographic features. So again, we can see the mountain front, we can see the catchment basin. So here we can see where the catchment area is, and then we can see the Kosi River. We can see that it's a very broad river with lots of different channels, which we also heard in the introduction. And we can also see the altitude in the Himalayas, and then things like borders and settlements. And so like that, you can continue to build your picture. Here, another map showing in much more detail what kind of deposits are there. Again, the mountain front, and then all the different paleo channels, but also active channels. What kind of deposits are there? Floodplains, also again, active floodplains, but also older floodplains. And what we could do now is also take a look, like, is there any different east to west? So in the same way, we could make another transect. Again, use that feature, show elevation profile. And then here we can see there is much less difference. Like it's very stable here around, as I said, about 50, 55 meters. And then towards the east, we do see that the elevation starts to get lower. So then in the same way here, another map, which is, as you can see, much more zoomed in. And this is where really the field observations, but then together with some really local scale type of maps and other data can help to put the picture together or can help to prepare. Let me zoom in to this map. And what you'll see is that this is a really detailed map of some of the drainage patterns of the Kosi River. Again, we can see those the active and old floodplains. We can see here the course of the river, and we heard in the introduction that this river is changing very rapidly. And what I already saw, so this map is from 2012. You can always easily check that back by using this feature, which has all the map source information embedded. So here we can see the caption, the source, and indeed we can see this was published in 2012. We can see who is the author, and so that you always have the references. And what we can see, if here again I play with the transparency of the map, we can see that some of these features that are on this map are still, are still what we see today. And then some other features already changed a bit. So like some other parts of the channel have already changed the course. So we can see some oxbows here also some more, here like a nice oxbow of an abandoned meander of the river. Then if we zoom out, of course, yeah, you could analyze in the same way, like the different patterns, what we can, for example, see, and there's also some information about this in the literature, but what we can already see just from looking at the satellite imagery in Google Earth is that here the river seems to be much more like a braided river with lots of different channels. And then here it's more a meandering river. And then at one point it joins the Ganges River. If we then zoom out, so changing topic, so this was more the geology, landforms, drainage patterns, but of course we can also take a look at other things such as rainfall, other climate patterns. So what you see here is also a map that I found on Geofacets with the average precipitation. And then here another map, again, much more local scale. Let me zoom in. Here of vegetation. So here, if we open this detail, so again, I downloaded this in the from Geofacets, but I always have the source, so I can see that this map is about plants in the Himalaya, that it shows. Here we can see that it shows the normalized differential vegetation index, which is a measure of what type of vegetation is there. And yeah, with that, you can analyze lots of different features. Of course, yeah, as I mentioned, so what I showed you now is mainly the physical features of the area with the close connection to the geosciences, but also using Google Earth, there is lots of other things that you could explore virtually. So for example, you can use the option for borders and labels so that you can see the different borders. You could switch on places so that we can see the localities, and let me now switch off the map so we can zoom in. And then we can see also, for example, roads and transportation so that we can see where are the main roads, maybe airports or other train stations. And then often in Google Earth, you also have some pictures and some short descriptions which could give some insights into certain localities or features, such as natural parks or other features. What you could also do is in some places, but here you really depend on the availability of such a feature, is explore virtually. And let me just close the elevation profile so that we have a bit more space to see a Google Earth. What you could do is zoom in on a specific area and then use this pacman to enter Street View. But as I mentioned, this is not available everywhere. You can see the blue localities. That's where typically it is available. And so unfortunately, we can see that in the case of the Kosi plain, there is not that much available. But here there is a location very close, just to the south, where actually the Kosi plain is joining the Ganges River. And so we can go there, and this can be nice views of mountains, but it can also be historical sites, such as in this case. And so then you can actually try to virtually walk. You can see these arrows, which will allow you to virtually explore. And just by clicking, we could go there and then see some of the sites. You can navigate using the arrows. We can look at it from different angles. You can see it from a side view, then also go here. And here you can see that you can really virtually explore. Still, of course, this is not the same as really going there, but it could be a good start, or it could support your field trip efforts. And of course, in the same way, you can explore also the satellite imagery. So for example, near the Kosi River, you can really zoom in. Let me exit the Street View again. So, and then put it back to north. So we'll just change the view and then zoom out. And so what we can then see here in really a lot of detail, we can see the river. We can see some of the bridges where they are crossing the rivers. Typically what we can see is that those are, so here, let me zoom out. We can go here a bit more to the north and then see here how the pattern changes to the braided river. And so like that, you can explore both from a top view, then of course, yeah, using the elevation profile and using the data that we found. And then if it's available, like almost like a virtual walk. And with that, I will go back to the presentation and then wrap up for questions. So what I just wanted to show you, like in summary, we did a virtual trip in the Kosi plain, which can, and I hope you've seen how this could support any training or how it could help with any preparations. But yeah, again, of course, this cannot completely replace the real field experience, the experience of sketching, observing, but it can really help because in the same way, we've been observing and exploring the area. We looked at the elevation, we looked at some of the different features, the drainage system, drainage patterns, rainfall, and then an archaeological or a historical site. And so with that, I would like to pass it back to Manish, to you for questions.
So thank you, Sandra, for this insightful presentation. And I can see there are a lot of compliments for you for your presentation, and there are a lot of questions as well. So at this time, I think we would like to deep dive into the questions, and we'll start our panel discussion. So I will hand over the floor to Vincent. And for the audience, I would like to give you a reminder. If you have a question that you have not yet submitted, please enter it in the Q&A chat box, and we'll try to get through as many questions as time allows. So over to you, Vincent. Now.
Thank you, Manish. First of all, thank you so much, Professor Alam and Sandra, for giving such an informative presentation. And I can see from the comments, like people are really interested into it, and they really found it interesting. So we are getting a lot of questions, but we will not be, we are sifting through it, and we'll pick up few of the questions, and whatever questions that we are not able to answer, we will get back to you over mail or any other format, right? So the first question, and this question is directed to Professor Alam. What are the main challenges that occur in the field work during this pandemic situation?
Okay, thank you, Vincent. So talking to my students who participated in the field work, I could identify some of the problems that they faced, even though they were working in their respective regions, they were doing field work in respective regions. One, the most important challenge was that of accessibility, because whenever they were going for interview to some people, because of this corona pandemic, people were not ready to entertain. There were always a fear, and the students are also quite fearful. And then there is the problem of public transportation. There was hardly any transportation during the pandemic situation. So most of my students use their own private means of transportation, mostly motorcycle. And then since hotels and restaurants were closed, so they could not get food in the field. So they had to take their own food and from their own home. And these are some of the challenges that the students faced while doing the field work.
Thank you, Professor Alam. The second question is how to do practical work or lab work during pandemic, and what do you think from your perspective is its impact on the overall research for the students? Again, this question is for Professor Alam.
Yes, it does have impact. I mean, there is no substitute to classroom practical teaching or physical lab work. I mean, but there are options, as I said, if these are the challenging times and if these are the uncertain times, one has to be creative, one has to look out for the alternatives. So I can see actually there are two alternatives. One is that we can make a video of the whole process of different steps involved in the lab work or practical classes, and we can share the video to the students. And the second, but the problem is that it is not interactive. I mean, because you cannot interact in video with the students. So the other option can be that we can have a live demo of field work or laboratory work. But the problem here is we do not have good internet connectivity, particularly the students, those who are from the remote part of the country. They do not have good connectivity of internet. That is a big problem. And further, even the universities do not have such facilities. They cannot record and telecast these practical classes and lab work. So we are also handicapped. Despite we are in central universities, we are still trying hard to develop the facilities so that we can face these challenges. So this is what I think can be done.
Thank you, Professor Alam. The third question is something which is related to what Professor Alam just said, that so the question is, during the pandemic, when a lot of students, they do not have access to high-speed internet, how do you think we can do virtual field trip, either using Geofacets or any other way? And this question is for Sandra.
Thanks, Vincent. Yeah, good question. Yeah, and of course, I think, as I mentioned, Geofacets has a global user base, and we know that this also, especially during the pandemic, actually, that the question of internet access may be challenging at times with so many people using the internet, like much more, than before the pandemic. So to emphasize, the Geofacets is an online solution. So yes, you in the case of Geofacets, right, you would need to have access to internet, but no specific requirements for like high-speed internet, like actually ensuring that the performance is good and that Geofacets runs smoothly is one of our key priorities as part of the product development of Geofacets. And I think secondly, I mean, with Geofacets, but also often with other types of literature, once you have the access and the rights for that content, right, like the access to that content, often in the case of Geofacets, you saw how we could download, for example, the maps. And so then maybe during and so you can basically save them and then use them and still continue your work during times of very or internet outages, so that you can at least still continue your work. So I think, yes, of course, yeah, with internet, it's easier, and the faster the internet, the faster it works, but there is no specific requirements. And in the case of Geofacets, we do spend like a lot of effort to make sure that performance is high for our global user base. Thanks.
Thank
Vincent.
you, Sandra. The fourth question is around again. So this question is, thank you, Sandra, for showing such an informative presentation on the Kosi plane. In terms of the content, does Geofacet has created proper reliable database for Indian subcontinent? How do you answer that, Sandra?
Yeah, thanks for that question. So actually, I highlighted some of the publishers in the society. So to emphasize, the Geofacets content base consists of peer-reviewed scientific articles. So in that sense, the trusted is part of that peer review process. And then on the topic of for India or for the Indian continent, I mean, also to emphasize here, I mentioned the global user base. And so Geofacets actually also has a global coverage. And so that includes India. I mean, here you could see for the Kosi plane, as an example, you could see that Geofacets has information on the geology, on the landforms, on drainage patterns, so hydrology, geography, but also vegetation. And so this applies also to other locations in India. And so in that sense, there's also specific journals focusing on this region, but also lots of journals that have a global coverage. And with that, of course, automatically also there's lots of content and information for the India region.
Thank you, Sandra. And this is one question which has been, quite repeated by a lot of people. Do you think Geofacets or any other virtual trip, software can replace the actual field trips?
Well, I mean, being a geoscientist myself and having gone through field training, I don't think it can completely replace field trips. I mean, of course, also, but it can support it. And this is not just during the pandemic, but also in general. I mean, for example, for my PhD, I went to Romania, and what I did, the field trip was one summer. I had to collect like lots of samples. And so what I did before going there is seeing what is already published, where did people already publish on samples on specific data, and then where are the gaps. And so with that, I could make like a field plan that is then really efficient, like not going and duplicating work that others have already done, but then really filling the gaps and planning efficiently. And so in that sense, yeah, I don't think it can completely replace it. It can help. And then of course, yeah, in times where it's challenging to go somewhere, it can help extra, like the situation that we've been discussing now.
Yeah. I think there are a lot of questions, but the last question that I'm going to take, and I'm going to answer that because this question has been repeated quite a lot, is how do we get access to Geofacets? So this is for all the students who are asking. So Geofacets is a tool which is subscribed by your institute, by the university or the college that you are currently in. So what you can do is you can ask your faculty members, ask your HOD, or ask your library, and we can get back to them, and we can discuss the details of how the subscription can work, right? So I know we are already running out of time, so these are the questions that we will be able to take during this webinar, and rest of the questions we'll try to answer over mail, right? Over to you, Manish.
So thank you, Vincent, for this engaging session. And before we end this webinar, I would like to express our sincere gratitude to our honorable speakers, Professor Yadav, Professor Alam, and Dr. Merton, for joining us for this session and sharing their perspective on the topic and addressing questions and queries from our audience. Thanks to our audience as well for joining us and sharing your questions and queries with us. And I would also like to inform the participants that in next 24 hours, they will receive an email from our team to download their certificate of participation, the recording link of this session, and the presentation download link. A feedback survey link will pop up on your screens after we end this webinar. So ladies and gentlemen, we are looking forward to your valuable feedback to create more impactful researcher engagement programs in future. So thank you for your time and have a wonderful day ahead. Goodbye. Thanks.
Thank you, Manish. Thank you, Dr. Alam. Thank you, Professor Yadav.
Thank you, Vincent,
Sandra.
Manish, and Sandra. Thank you very much. It was really a nice presentation. I really learned so many things. I mean, it's such a useful software.
Thank you, sir. We really enjoyed, and you know, the creative ways that you applied for the field training, I was really impressed with that, and I'm sure everyone else is. And that report was really unique and creative. So thanks to you for sharing that, sir.
Thank you.
And thank you, Professor Yadav.
Right. Thank you, Sandra. Bye-bye.
Thank you.